Hello guys, welcome back to a new video, and today we're going to discuss about the Krok 1 Rapid Revision Histology part, in which we'll study some question from the base and some key points and some concepts questions and some other important stuff. So in the Krok 1 Rapid Revision start from the hypersensitivity. So we know that hypersensitivity, it's mainly the four types, and giving you name and of hypersensitivity and the examples of the hypersensitivity. In another video I will discuss everything regarding hypersensitivity. So type 1 hypersensitivity, it's known as anaphylactic, immediate, reagents or atopy, because it's occur very quickly, like 15 to 30 minutes it will occur. So that's why it's called immediate or anaphylactic. And what are the example of this? Examples like bronchial asthma we have, and further we have urticaria. Then second is antibody mediated. So antibody mediated type 2 hypersensitivity. So antibody mediated, it may simply means like B cell mediated we can say. So B cell mediated, it's our type 2 hypersensitivity, or we can say immunoglobulin mediated. Like example, if I take that blood transfusion, so blood transfusion is a good example for the type 2 hypersensitivity. So blood transfusion. So what happen in the blood transfusion? There is a antibody mediation of type 2 hypersensitivity will occur. In type 3 hypersensitivity, what will happen? Type 3, it's known as immunocomplex hypersensitivity. So there is a complex formation or immunocomplex hypersensitivity with the type 3 hypersensitivity. Example for type 3 hypersensitivity, you can take systemic lupus erythematosus and glomerulonephritis. So simple glomerulonephritis, if in most of the cases it's type 3 hypersensitivity, but if we talk, then it can be type 2 hypersensitivity also. Next is type 4 hypersensitivity. So what happens in the type 4 hypersensitivity? It is a delayed or T cell mediated. Why it's called delayed? Because in this the timing is more than 24 hours. If so more than 24 hours timing or the hypersensitivity arising after the 24 hours, then it will be type 4 hypersensitivity, and it is mainly the T cell mediated hypersensitivity. Or you can, in the question they can give you cell mediated immunity. So cell mediated immunity, who provides the cell mediated immunity? That is the T cell. So that's why it's called the T cell mediated hypersensitivity. What are the examples? There are lots of examples like granuloma, leprosy, Mitsuda test, Mantoux test for the tuberculosis. That's also a type 4 hypersensitivity example. Okay, the next question is about the poikilocytosis. So poikilocytosis, it simply means change in the shape of RBC. So RBC can change their shape or change their size. So if the changing in the shape of RBC, then it is called poikilocytosis. But if there is a changing in the size of the RBC, then it's simply called anisocytosis. So we can write it's like PPJA. So remember PPJA. So P here denotes poikilocytosis, and here also the P in means P in the shape. So PP, and A here that is jaw, and Z here that is in the size. So PP jaw, that's a poikilocytosis and anisocytosis. Next thing about the immune organs. So what are the immune organs? The immune organs that provide the immunity or help or have important role in the immune system. So they are the central and the peripheral immune organ. There are the two types, central and the peripheral. So central, it simply means thymus and the red bone marrow. Thymus and the red bone marrow are the central immune organs, and the peripheral, they are the tonsils and the lymph nodes and the spleen. Tonsils, lymph node and the spleen, that are simply peripheral immune organs. Now central immune organs, they are thymus and the red bone marrow. They are antigen independent. What does it mean by antigen? Like any foreign antigens. So any foreign antigens that enter in our body, any foreign antigen that enter in our body, it's called antigens, or any foreign particles is called antigen. But what the thymus and the red bone marrow, they produce only the immune cells, or the thymus, the like thymus produces thymosins. Red bone marrow gives the most of the cells like RBC, WBC, all the cells produced from the red bone marrow, but they are not antigen dependent. because they are antigen independent. That's why they are the central immune organs. And peripherals, they are the antigen dependent. Antigen dependents like tonsils, lymph node, and the spleen. They act as immune organs when the antigen will come, so they will act as immune organs and they produce the immune cells. Next is tonsils. About the tonsils, remember for the tonsil, it is the only lymphoid organs. It is the only lymphoid organ with epithelial lining. So only lymphoid organ with epithelial lining is the tonsils. So only lymphoid organ with epithelial lining, that is the tonsil. All other don't have the epithelial lining. So they are the like nasopharyngeal tonsils. Then tubal tonsils they have the palatine tonsils and the lingual tonsils, and palatine tonsils or tubal tonsils. So tubal and the palatine, they are the paired and nasopharyngeal or lingual, they are the single. Together when they together they forms a ring that is known as Waldear's ring. But they forms a Waldear rings. Remember about the tonsils. So tonsils, this is not about Walder, this is tonsils. So not all the tonsils have the numerous crypts present in there. So and the lymphocyte arranged as a lymphatic nodules. Lymphocyte arranged as the lymphatic nodules. So remember that tonsils have the numerous crypts and lymphocyte arranged at the lymphatic nodules. This is an important point when you do the MCQ questions. So you can get some keywords in the question, so you get it easily. Like if there is numerous crypts easily, so which immune organs will be there. So they can give you tonsils, lymph nodes, spleen. So you can easily identify that it's a tonsils. Then lymph node. Lymph node, it's bean-shaped organ or bean-shaped immune organs. Then who is the bean-shaped organ in our body? That is our kidney. Kidney is the bean-shaped also. Here the lymph node is also bean-shaped. What they have medullary cords present. Which cords they are present? Medullary cords. So medullary cords किसमें present होंगे आज से? That is lymph node. Then there is a trabeculi. So trabeculi present in the lymph nodes. Okay. They have the both like cortex and the medulla. So follicles present in the cortex known as lymphatic nodules. So follicles in the lymph node or the cortex of the lymph node is known as lymphatic nodules. And the cords, they are present in which region of the lymph node? That present in the medulla, or we can say medullary. That's why it called it medullary cords. So remember, you can get some keyword from here, that bean-shaped, medullary cords and the trabeculi. These are the characteristic features of the lymph node. Now talking about the spleen. So spleen have the two parts, white pulp and the red pulp. So spleen have the two parts, which pulp? White pulp and the red pulp. White pulp having the eccentrically placed arteriole, that I wrote it here, that they have central artery present. So they have eccentrically placed arterioles. And red pulp, what I'm talking about, that it's made of the sinusoids and the cords. So red pulp is made up of sinusoids and the cords, and the white pulp, they have the eccentrically placed arteriole. Then what about the liver? Liver have central vein passings. So remember, you know the love, LOVE. So the L for liver and V for vein. So central vein always pass through the liver, and the spleen having the central artery. So don't confuse that who have the central vein, who have the central artery. So liver, remember love, or liver is like mother of us. So that is the LOV, love. So L for liver and V for vein. Next is thymus. Thymus, we know that is the endocrine organ also, or immune organ, peripheral immune organ also. So thymus, it produces a hormone that is known as thymosin. So thymus, it produces hormone that is known as thymosins. Now they have the Husserl's corpuscles present. So these are the characteristic features of the thymus. What they have the Husserl's corpuscles present. They undergo the age involutions. The which immune organ or which endocrine organ or which organ of our body undergo age involution. What does mean by age involution? Age involution simply means that the organs, it will decrease in the size when the age will grow, or the person will grow, thymus will start to reduce. So that is the age involution. And if thymus will be absent from the baby, or from the thymus will not produce the thymosins, then that is known as Di-George syndrome. That is Di-George syndrome. Got it? Okay. So if they you wrote it here, absence, so if absence, then Dijor syndromes, the chromosomes which affect chromosome 22 defect is seen in these patients. Then red bone marrow. So red bone marrow and thymus, these are our central immune organs. These are our central. So red bone marrow, it produce the red blood cells. And which hormone act on the red bone marrow? Question here. Then which hormone act on the red bone marrow? That is, yes, that's hormone that, yeah, great, erythropoietin. That is erythropoietin. And which, who produce the erythropoietin? That is kidney. So kidney produce the erythropoietin that act on the red bone marrow. समझ में आया? Yes. ठीक है. Next is our amputation. So what is the amputation? Amputation, it simply means removal of organs. If I will cut my hand, so that is called amputation, or removal of the organ. Cutting of any organ, cutting of any like my hand, so that is the amputation. So if amputation will occur, then the phantom pain will be there. So this is the question that given in the base, that amputation, which pain will be there? Phantom pain. But if they will give in the question that gunshot pain, so gunshot pain, we have the cosalgic pain. So if we have the gunshot pain, so in the gunshot pain, which pain will be seen? Cosalgic pain. Protopathic pain or seen in the like any glossitis disease or gastrointestinal disease, we see the protopathic pain. So three pain, remember for here, that phantom pain arise from the amputation, cosalgic pain arise from the gunshot, and protopathic like glossitic, like inflammation of something, that will be protopathic pain. So that is the cosalgic pain and protopathic pain. Next question about granuloma. So granuloma, I already told, that is which hypersensitivity? Type 4 hypersensitivity. So remember the characteristic feature of granuloma, that they have the palisade arrangement, or we can say sandwich arrangement seen in the granuloma. So which arrangement seen in the granuloma? Palisade arrangement or the sandwich arrangement seen in the granuloma. Then the some granulomatous cells. So what is the granuloma? It is a combination, like if the bacteria and the macrophage will combine, they forms the granuloma. So bacteria along with macrophage, when they will combine, they will forms granuloma. Okay. So there is granulomatous cells. So for the tuberculosis, if I will say, so tuberculosis which bacteria? Mycobacterium tuberculei. Yes, that's which granulomatous cells, that is the Langerhans cells seen in the tuberculosis. For the leprosy, like virchow cell, I told the love now. So remember again love now. That leprosy virchow cells. Rhinoscleroma muculis cells. So mucul, that is mucul. So mi. Got it? Muculis cells. So you can remember it, muculis cells. And mucul have what? Rhinoscleroma. Not serious. Syphilis, gumma bodies. Syphilis, what they have? Gumma bodies. SGB. Okay, SGB. So tuberculosis, Langerhans cells, leprosy, virchow cells, rhinoscleroma, muculis cells, syphilis, gumma bodies. याद हुआ कि नहीं? हो गया. Okay, बहुत बढ़िया. Then lungs we have three types of the cells. So if I talk about the lungs, so my lungs have the three type of the cell. Of course you will have also. So there the pneumocyte alveolar cell type 1 present. Yes sir. Pneumocyte alveolar cell type 2 or alveocyte type 2 present. Yes sir. Alveolar macrophage present. Yes sir. So these are three type: alveocyte type 1, alveolar cell type 2, and alveolar macrophage. So these are the three types of the cell present where in the lungs. So remember that alveocyte type 1, they undergo the simple diffusion or the gas exchange. So if there will be the gas exchange, so which is a cell of the lung is responsible? That is alveolar cell type 1. Then second, pneumocyte or alveolar cell type 2. So pneumocyte and alveolar cell type 2, they produce which surfactant? What they produce? Surfactant. What the surfactant do? They reduce the surface tension. What the surfactant do? They reduce the surface tension. because the layer between the of the lungs, they are in close contact with each other, so produce surfactant, they will reduce the surface tension and prevent the collapsing of the lungs. Or in the question they can give you recede, prevent tendency to recede. So recede, it simply means collapse. Okay, so pneumocyte alveolar type 1, type 1 simple diffusion, type 2 surfactant production. It who is the precursor of the type 2 alveocyte type 2? That is the alveocyte type 1. Then macrophage, alveolar macrophage. We know that macrophage, they involved in the phagocytosis. So they involved in the phagocytosis. So phagocytosis simply means, so remember, they engulf the foreign bodies. So any foreign bodies, it will come, then which, what will happen? Who will come? Alveolar macrophage will come. And remember the emphysema. So emphysema is a respiratory disease in which the macrophage will come. It will produce the elastase enzymes, and that will the breakdown of the wall of the lungs, and it will form the bulky lungs, or the baggy form of the lungs. So that's why the alveolar macrophage here, any foreign material in our body will come that act as a phagocytosis. What are the foreign bodies or in the emphysema? That is the coal particles arising from the smoking. So these are the foreign particles, and who play the roles? Alveolar macrophage. Then the next question about the parietal and oxyntic cell. So remember that which cells in our body, or which cells we studied till now, contains the maximum mitochondria. So remember the parietal or the oxyntic cells, we already study in the physiology again. Parietal and oxyntic cells that secrete the HCl or gastromucoprotein. So that cells, and the road cells are responsible for, yes, twilight vision. And the alveolar type 2 or alveocyte type 2, they contain the maximum mitochondria. So in the question they can give you which cell of the lungs, or which cell of the lungs contain maximum mitochondria. That is the alveocyte type 2 or alveolar type 2 or pneumocyte type 2. Okay. So which is this here the question, the surfactant that produced by the type 2 alveolar cells. So what are the composition? So what are these are the composition? So what are the composition we have? DPPC, dipalmityl phosphatidylcholine, sphingolipid, phospholipid, lecithin, calcium. You can remember it series: DPPC, sphingolipid, phospholipid, lecithin, DPPC, sphingolipids, phospholipid, lecithin. So these are the surfactant compositions. So anything that you need to cram or just rectification, so go through that: DPPC, sphingolipid, phospholipid, lecithin, DPPC, sphingolipid, phospholipid, lecithin. Take like a song. Okay. Then there is a surfactant protein. So surfactant protein, there are the 4 type: A type, B type, C type, D type. So A, and remember the B and C, they are hydrophobic. Phobia means hate. So they hate the water. And A or D, they are the hydrophilic. So remember, you can remember it like that: BC. So we know that in our category there is OBC category. So remember the BC category, or be careful category. So you can remember be careful category. They hate the water. Water hater. They hate the water. Be careful. Then capillaries. Talking about the capillaries, so capillary, these are the 3 types. What's capillary? Yes, continuous capillaries, fenestrated, and the non-continuous or the sinusoidal. So continuous, so this is the continuum. Continuum means no gap, anywhere, no gap. So no gap, no pores, continuous. No gap, no pore, continuous capillary. What the example? Brain, lung, skeletal muscles, smooth muscles. Brain, lung, skeletal muscles, smooth muscles. So these are the continuous capillary. So continuous capillary, these are the no leakage of the blood, no leakage of anything, so no leakage of no gaps will be there, no pores will be there. Then fenestrated have the small gap. So small gap. Small gap. So small gap, like little things will be passed, little things like kidney and the GIT. In the kidney we know that it will happen reabsorption and resecretion. So little thing we need. So that is the fenestrated. Then non-continuous or the sinusoidal, there is wider gap, बहुत बड़ा बड़ा gap होने चाहिए वहाँ पे. That is the red bone marrow. Why in the red bone marrow? We know that red bone marrow it produce, yes, it produces the red blood cell. It produces the red blood cell. It produces the WBC. It produces platelets. So that's why red bone marrow, RBC, WBC, and the platelets, they need wider gaps to release their RBC, release their WBC, and release their platelet. That's why they're called non-continuous, or they have the sinusoid or the wider gap capillaries. Liver and the spleen. So three, remember, red bone marrow, liver, and the spleen. So remember, liver, spleen, red bone marrow, these have the sinusoidal capillary. Brain and the lungs. lungs में से हमें हवा नहीं निकालनी है, तो इस तरीके से याद रखो कि लंग्स में से हमें हवा नहीं निकालनी है, मतलब अगर हवा निकली तो क्या होगा, उसमें गैप होंगे. सो दैट्स व्हाई दैट्स कंटीन्यूअस. सो कंटीन्यूअस होगा तो मतलब उसमें से हवा नहीं निकलेगी. दैट विल बी द लंग्स. ठीक है. नेक्स्ट, arterioles. So in the question sometimes they ask which is the resistance vessel and which is the capacitance property. So remember the arterioles, the smallest vessels, they have the resistance, they are the resistance vessel. Veins, remember, veins have the capacitance, veins have the capacitance. Then the one important more keyword here, that is the lymphatic capillaries and macula densa. We are talking about the capillaries here. So remember which capillaries don't have basement membrane, or in sometimes they don't give you absent of the basement membrane, sometimes they give you thin basement membrane. So that is lymphatic capillaries and macula densa. Macula densa can have thin basement membrane, or so remember, thin or no, in the question they will give you lymphatic capillaries or macula densa. Okay. Okay, the next we do urification or ammonification. So what for the ammonification, in the brain we have what, ammonia, but brain in the and heart and the muscles we have ammonia. But we have ammonia, but brain and heart muscles, ammonia is very toxic, it can be injurious to my health, please remove it. So for the removal we have the glutamate and the alanine, our best friend. So when the brain and the heart and the muscles having high ammonia, so what the glutamate will do, it will transport ammonia from the brain to the heart, from to the liver. So it will give to the liver all the ammonia, it will give to the liver. Glutamate, it will take the ammonia from the brain and the heart and give it to the liver. And alanine, it will take them from like muscles and it will into the urea. So it will convert ammonia into the urea with the help of urea cycle occur in liver in both cytoplasm and mitochondria. In both cytoplasm and mitochondria. Okay. So remember, if we know that hug, HUG, so heme cycle, urea cycle, and gluconeogenesis. So they both occur in the cytoplasm and the mitochondria. So now the urea is got it from the liver with the help of the urea cycle, but urea, it takes too much water consumption, so we also need to do that, or so we will go to the urea will go to the kidney and we will excrete it. So remember, for ammonia detoxification we need loads of water to excrete that materials. That's why ammonia is excretory material for the fish or the like some arthropod or the pisces family, like some of our fish and all. So that's why they excrete the ammonia and we release the urea. And if we talk about like birds and all, so they release in the form of the uric acids. So what the excretory material for the birds, that is the uric acid. So they excrete in the form of uric acid. The next question is about the collagen. So collagen, remember, it's the most abundant protein in the body. So most abundant protein in the body, collagen. Yes, yes. Most abundant protein in the blood. Yes, I can hear. That is albumin. Great. So albumin is the most abundant protein in the blood, but collagen is the most abundant protein in the body. Then there are the four types of the collagen I am discussing here. The type 1, type 2, type 3, type 4. Type 1 it present in. So type 1, remember 1. So 1 means 1, bone. So it present in the bone, skin, tendon. Type 1 present in the bone, skin, tendon. Type 2 present in the cartilage. Type 3 present in the reticulin fiber, blood vessels and the aorta. Okay. Then type 4 it present in the basement membrane. So type 2 cartilage, type 1 present in the bone, skin, tendon, type 2 present in the cartilage, type 3 reticulin fiber, blood vessel, aorta, type 4 present in the basement membrane. If absent, then if type 1 is absent, like type 1 collagen fiber, so it present in the bone. So in the bone, if it will absent, it cause the disease that osteogenesis imperfecta. What they cause? Osteogenesis imperfecta. Now if type 2 collagen will be absent, they cause absent in the cartilage. So cartilage means cartilage absent, A4 absent, chondroplasia, absence of the cartilage. Then type 3 if absent, then it cause the Ehlers-Danlos syndrome. It cause the Ehlers-Danlos syndrome. Type 4 it cause the Alport's syndrome. Khatam, bye bye, tata. Then next is our islands. Khatam means about cartilage. Then islands. Islands we have the surface ectoderm. So surface ectoderm. So for the eyes, like some point is there that islands it originates from the surface ectoderm. Retina it originates from the ectoderm. But choroid having the blood vessels. So choroid what they have? They having the blood vessels. That's why they originate from the mesoderms. So remember the islands, they are originate from they are surface ectoderm originator, retina ectoderm derivative, but choroid these are the central or the chief minister, that is the choroid mesoderm, chief minister choroid mesoderm, blood vessels they are having. Then this about some base question. Now let's talk about some cell organelles given in the sometimes they ask about this. So first we have the endoplasmic reticulum. What is the cell organelles? The organelles present inside this. So this is the cell. So organelles present inside the cells are known as cell organelles. Endoplasmic reticulum. So there are the two types: rough endoplasmic reticulum or smooth endoplasmic reticulum. Okay. So rough it in terms of granules. So if I will say that if this is the endoplasmic, okay, let me light it this is the endoplasm. So if they are having some granules here, so these are granules, they are the ribosomes. So these granules are known as ribosomes. Okay. So ribosomes, rough endoplasmic reticulum or granular, that's why called granular. Why they are the rough? That is the due to presence of granules. And what are the granules? These are the ribosomes. So ribosome present or the granules. What is the function of the rough endoplasmic reticulum? So what is the function? That is the protein synthesis. So protein synthesis. What is the function of ribosome? Protein synthesis. So that's why the function of rough endoplasmic reticulum is also the same, that is the protein synthesis. Second, the smooth endoplasmic reticulum or agranular. So it means they have a ribosome absent. Ribosome absent. So ribosome absent with the function absent ribosome. It will smooth. So there is a no anything will be there, like smooth surface. So smooth, that's endoplasmic reticulum, or we can say granules are absent. So that agranular endoplasmic reticulum. It help in the lipid synthesis, storage of calcium, and important, that is the detoxification of the drug. So there are three functions: lipid synthesis, storage of the calcium, and the detoxification of the drugs. You will never forget this. Got it? Yeah. The next is Golgi apparatus. Next organelles we have the Golgi apparatus. So it is the post-translational modification. So what is the function? Post-translational modification and sorting of the protein. And there are the two phases, like cis phase and trans phase. Cis or trans side they have. So from the cis side, the metal will end, or one important point you can remember, that they functions of exporting and formation. In the option they will give you something. So exporting and formation function of Golgi apparatus. So they have the cis and the sort, they were the function sorting of proteins post translation modification. These are the function of Golgi apparatus. Now the next organelle is lysosomes. So lysosome, it simply means suicide bag. So lyso also known as suicide bag or residual bodies. So what is the function of the lysosome? So why they called suicide bag? Because they are having the hydrolytic enzymes. They are having the produce the hydrolytic enzymes like enzymes from the gastrointestinal tracts, or some other enzymes like that involves the water hydrolysis, that involves the hydrolysis process. That's hydrolytic enzymes. So what are the functions? Like distraction of unwanted substance or the bacteria, any foreign body, so they will degrade it, or they have the important role in the apoptosis and necrosis, or the process of the cell death. They have important role in the process of the cell death. That's why they sometimes they act as a phagocytosis. Then peroxisomes. Peroxisomes, they do the distraction of the free radicals by catalase enzymes. So we know the catalase enzyme, it act on our hydrogen peroxide, and hydrogen peroxide we know that is our free radical. So it causes the destruction of the free radical with the help of catalase enzyme, that function of the peroxisome. Another function is oxidation of the long and very long chain fatty acids. That's the other function of peroxisome. Next is cytoskeleton. Cytoskeleton, it acts as the bone of the cells. So it acts as the bone of the cell. Then what they do, they provide the strength to the cell. They provide the strength to the cell. So who gives the strength, or the give the give the bahubali to the cell, that is the cytoskeleton, or providing the strength to the cell, that is the cytoskeleton. So these are like, it can be microtubules. Microtubules are like big filaments. It can be intermediate form in the intermediate filament, that is the most abundant, and they are the intermediate in nature. And microfilament, like small filament, they are known as microfilament. So which is the most abundant? That is intermediate filament. Which is the small filament? Microfilament. Which is the big cytoskeleton filament? That is microtubules. Okay, so let's now talk about the epithelial tissues. So epithelial tissue, you need to just took the example. I just write the example here, that to learn the example, because that's important. You know, I hope you know everything about like what is the squamous with the cuboidal. So it's just simple. I will discuss. So there are the two type mainly. Just I'm not going too details. So there is a simple epithelium and the compound epithelium. So simple epithelium, these are the single layered. Simple epithelium, these are the single layered. If I will say this is like single layer, so this is the simple epithelium. So this is the simple epithelium, single layered. Compound epithelium, these are the multi-layered. Multi-layered in terms of, so these are of type multi-layered or compound epithelium. So let's talk about simple epithelium. So simple epithelium, simple squamous. So squamous, it simply means that flat like cells. So these are the flat like cells will be there. So these are the simple squamous epithelium. Where they present? They present in the 3BA. They present in 3BA. So 3B which? Bowman's capsules, blood vessels and the body cavities. अगर किसी बॉडी की लाइन करने, ब्लड वेसल्स की अगर लाइनिंग करनी हो तो कौन आएगा? सिंपल स्क्वेमस एपिथेलियम. इफ नीड एनी बॉडी एक्टिविटी लाइनिंग, हु विल कम? Simple squamous epithelium. If I'm Bowman's capsule, we know that for the Bowman's capsule layer, that is the simple squamous epithelium. Got it? Then alveoli. So for the alveoli, we have the simple squamous. It's again the cavity inside, so that will be the alveoli. So alveoli, Bowman's capsule, blood vessels, body cavity, simple squamous epithelium. Simple cuboidal epithelium. Simple cuboidal epithelium, it simply means like cube like structure. So cube-like structure or cuboid-like structure, that is the simple cuboidal epithelium. So you know the tick tock, that band in India now. Got it. बहुत बढ़िया हुआ. Then toke, so tick toke, take the toke. Toke means T for thyroid follicle, G for or O for germinal epithelium of the ovary, and K for kidney tubules. Kidney tubules, it simply means like PCT and DCT. Okay, so can I spread this one? So if I will say this is the PCT, this is the DCT, DCT. So that is the PCT, this is the DCT. They have the simple cuboidal epithelium and thyroid follicles and germinal epithelium of the ovary. Next is simple columnar epithelium. So columnar, it simply means like column-like cells. So if you have the column-like cells, so it simply means the columnar epithelium. So this is the columnar epithelium. So they present in the stomach and the large intestine. Why भाई small intestine ने कौन सा गुना किया था? Why the small intestine don't have simple columnar? They have the simple columnar, but what? They have simple columnar, but they have some finger-like projection, that is the microvilli present on the surface. So simple columnar with microvilli, small intestine, gallbladder, because gallbladder we need to storage of food, storage of bile storage. Yes, we need to store the bile, and from the small intestine we need the for absorption. What the microvilli do? They will increase the surface area, more surface area, more absorption, more surface area, more storage. Yes, so that is the increase surface area. So who increase the surface area? Microvilli. So microvilli increase the surface area. Yes sir, that is the gallbladder and the small intestine. Yes sir. So they have the columnar also, simple columnar with microvilli, that is gallbladder, small intestine. But what if about the eustachian tube and the fallopian tube? They also have the columnar, simple columnar epithelium, but again, yes, again what? Again what? Again they have simple columnar epithelium. Again they have the cilia. Cilia, they helps in motility. They provide the motility. So when we need the motility in the fallopian tube for motilation of the ovary or ovum, not ovary, the ovum, for motilation of ovary or for motilation of ovum we need for motility. So it present in the fallopian tube. So did you see any animation about the fallopian tube? So you will see the loads of the cilia will be there, that will move the ovum from ampulla to the towards like from the infundibulum to the ampulla and into the fallopian tube. Same as in the eustachian tube, we have the loads of the cilia. That's why the simple ciliated columnar epithelium. So there is a stomach and the large intestine, and stomach and the small intestine and the gallbladder and fallopian tube and the eustachian tube. So all have simple columnar epithelium. So all have simple columnar epithelium. But in small intestine and gallbladder having microvilli. Microvilli, why? Because they increase the surface area. They increase the surface area. So they increase the surface area. That's why the small intestine gallbladder have the microvilli. That simple columnar epithelium with microvilli. Fallopian tube, eustachian tube, they have the cilia. So simple columnar or ciliated, simple columnar ciliated epithelium, simple ciliated columnar epithelium as it is. Simple? Yes. Then compound epithelium. Compound epithelium, that the non-keratinized stratified squamous epithelium. अबे यार squamous ठीक था, stratified तक भी ठीक था, अभी non-keratinized क्या है और keratinized क्या है और stratified क्या है? So stratified it simply means multi-layered. Stratified means multi-layered. Then non-keratin. So keratin, it is the like dead substance So that present like on the surface of all of the upper layer. So that is the keratin. It's like a dead layer that forms around or forms or cover the surface of the compound epithelium. That is the keratinized. That keratin is seen in the thick skin and anal verge of the anal canal. The last part of the anus, that is the anal verge of the anal canal or thick skin, or we can say the last part of the GIT. So that is seen in the keratinized stratified squamous epithelium. So remember that all the GIT like oral cavity, esophagus, tonsils, tongue, vocal cords and vagina, all they have non-keratinized stratified squamous epithelium. Why they are there? Because multi-layered. Multi-layered it can be any, but outer layer will be the flat cell or the squamous layer cell. Squamous layer will be there. Multi-layered it can be in the forms like cuboidal forms, columnar forms, in any forms it can be there below, but outer or the upper layer will be the which layer? Squamous layer will be there for the upper cells. Got it? Then stratified columnar. So stratified columnar कहने का मतलब कि below cells should can be like squamous, but outer cell will be cuboidal. Outer cell will be cuboidal, or the upper cell will be cuboidal. That's why it's known as stratified columnar epithelium, seen in the membranous urethra and penile urethra. So it's seen in the two type of urethra. Which urethra? Like membranous and penile urethra. And so the urethra have the three types. Urethra have the three type. Which one? Prostatic, membranous and penile. So in both these we have what? Simple compound or the squamous. Oh, sorry, what I'm writing. Stratified columnar epithelium. Stratified columnar epithelium. Then prostatic we see, that is our transitional epithelium. So transitional epithelium, it will where the volume. So volume needed. So for if I will talk about the urinary bladder. So for urinary bladder, they store our urine. So they need more space. So when the urinary bladder will stretch, they need to when the like our urine will fill into the urinary bladder, or it like full cross the limit. So it need to the transit, or need to be some space. Most need some space. For that's why they need transitional epithelium. And same as in prostatic urethra. So prostatic urethra, transitional epithelium we will see. Then the question here, the lymphatic nodules or the follicles seen in. The question that we discussed in the immune organs. So the lymphatic nodules or the follicles seen in. So what will you answer? Think. Lymph nodes, spleen, tonsils, all of the above. Choose your answer in your mind. And so lymph node. Okay. So lymph node, yes, they have the lymphatic nodules or the follicles. Spleen, yes, spleen also have. Tonsils, yes. So what the answer? Answer is the all of the above. So lymph node, spleen and the tonsils, they all have the lymphatic nodules seen. Lymph node, spleen and the tonsils all have the lymphatic nodules or the follicles seen. So next is our some key points here that I will discuss, like the questions, like some from the base, some from the ministry. So let's discuss about the desmosome. First is about desmosomes. So desmosome is, if in the question they will give something like electron dense substance, so that is the desmosomes. Next is the basal cell. So basal cell, that we know that it helps in the regeneration and repair. It helps in the regeneration or repair. Like example, swan cell. So swan cell is the help in the reparation of the nerve cells. Satellite or myosatellite cell, muscle cell, periosteum, bone tissue, endonucleus, DNA regeneration or DNA repair. So swan cell, nerve cell. Satellite or myosatellite cell, muscle cell, periosteum, bone tissue, endonucleus, DNA. The next is vein of non-muscular type. The vein of non-muscular type, remember, they don't have tunica media. They don't have the tunica media. We know that the blood vessels of the layer of the blood vessels, tunica externa, tunica media, tunica interna. So vein of non-muscular type, they don't have tunica media in their wall. The next is artery of the muscular type. So artery of the muscular type, tunica media present, the smooth muscles present. Tunica media present and the smooth muscles present is seen in the artery of muscular type of the tunica media. Next is embryonal and the mature. So embryonal, these are the major calyces absent. So embryonal, remember, they have the major calyces. So if in the ask like which is the embryonal kidney or which is the mature about, so remember, for the embryonal they are the major calyces absent, and for the mature they have the both major and the minor calyces are present. Next is seborrhea. Seborrhea is cell of the sebaceous gland, is known as the seborrhea. Then the next or the last is unformed dense connective tissue. What they provide the skin strength. So you can just remember all these key points as it is, because this like something asked from the base from the ministry or in the previous year paper. So just need to remember this. So okay, so let's finish it about the histology, and bye bye, take care, thank you.